Hi, and welcome to How to Improve Science Performance Through Strategic Note-Taking.
Welcome. Today we're going to talk about potential and kinetic energy. But before we start, what is energy anyway? You must remember the following about energy. Energy is the ability to do work, the ability to cause matter to move, and the ability to cause matter to change. Energy is measured in joules and calories. There are different types of energy, but today we will focus on the two main types, which are potential and kinetic energy. You must know that potential energy is stored energy. It is energy of position, the amount of usable energy in a body at rest. And it is also called gravitational potential energy. You must also note that potential energy can be increased by increasing the height and increasing the mass. Have you ever sat at the top of a slide or prepared to skateboard down a ramp? If so, you have experienced potential energy. Potential energy is stored energy and also referred to as energy of position. When you're at the top of a slide, your body has stored energy waiting to be released when you go down the slide. A stretched rubber band has potential energy and when released will fly forward. Potential energy also exists in foods. Foods contain stored energy, stored chemical energy, which is released upon digestion. What type of potential energy is dependent upon height above the Earth's surface? Any object above the Earth's surface has gravitational potential energy. A bridge has gravitational potential energy, as does an airplane. The equation for gravitational potential energy is as follows. Write this down. Gravitational potential energy equals mass times height. As the mass of an object and its height above the surface increases, so does its gravitational potential energy. Perhaps you have heard the expression, the bigger they are, the harder they fall. This is true of gravitational potential energy. A large tree has more gravitational potential energy than a small tree. If we cut down a small tree, it will come down with a smaller force than if we cut down a large tree. Kinetic energy is energy of motion. Energy an object has because it is moving. Kinetic energy can be increased by increasing mass and increasing speed. Which has more kinetic energy? A tennis ball hit by a racket or a race car speeding around the track? That's right. The car has more kinetic energy. The amount of kinetic energy an object has is directly related to both its mass and its velocity. The equation for kinetic energy is, write this down, kinetic energy equals mass times velocity squared divided by 2. Would you rather be hit by a tennis ball tossed towards you lightly or a tennis ball hurled towards you with great speed? Hopefully, most of you would rather be struck by a ball that was lightly tossed. This is because it has less kinetic energy. Have you ever slid down a slide or skateboarded down a skateboard? If you have experienced kinetic energy. Kinetic energy is energy that an object has as a result of its motion. All moving objects possess kinetic energy, which is determined by the mass and the speed of the object. Potential energy is energy an object has as a result of its position. Potential energy is stored energy that has not yet been released. Gravitational potential energy is potential energy that results from an object's gravitational field and is equal to the object's weight multiplied by its height. For example, a book placed on a shelf possesses gravitational potential energy because of Earth's gravity. If the book were moved to a higher shelf, it would gain potential energy. Our favorite example that demonstrates both potential and kinetic energy is a roller coaster. Although roller coasters have changed quite a bit since the ride first became popular, the basic design principles remain the same. Whether the ride consists of an old wooden track with a few hills and turns, or a modern steel track with a variety of corkscrews and loops, all roller coasters rely on the concepts of potential and kinetic energy. For most roller coasters, the gravitational potential energy of the cars are at its peak on the top of the first hill, so that there's enough energy available for the rest of the ride. Traditionally, the coaster cars are pulled up by a chain. As the cars climb, they gain potential energy. At the top of the hill, the cars have a great deal of gravitational potential energy, equal to the car's weight multiplied by the height of the hill. When the cars are released from the chain and begin coasting down the hill, potential energy transforms into kinetic energy until they reach the bottom of the hill. As the cars ascend to the next hill, some kinetic energy is transformed back into potential energy. Then when the cars descend this hill, potential energy is again changed to kinetic. The conversion happens throughout the ride between potential and kinetic energy. In reality, the conversion between potential and kinetic energy form is not perfect. The force of friction acts on the moving cars, decreasing the total amount of energy in the system. The energy is not lost, however. It is transformed into thermal energy, which can be detected as an increase in the temperature of the roller coaster's track and car wheels. The first hill of a roller coaster must always be the tallest, so that the coaster gains enough potential energy to travel the length of the track. Energy is never lost. It is just transferred from one form to another. Why is kinetic energy important? Kinetic energy lets us do everything from running a mile to typing on a computer. When an object has energy, it has the ability to cause change. Kinetic energy and potential energy are the two types of energy that relate to motion. Potential energy is stored energy. It increases or decreases depending upon an object's position or condition. The higher you travel up a mountain, the more potential energy you gain. Kinetic energy is energy that an object has because of its motion. If it's not moving, it doesn't have kinetic energy. When you start to travel down a mountain, your potential energy is then transferred into kinetic energy. The amount of kinetic energy an object has depends on its mass and speed. A fast-moving object with a lot of speed will have a lot of kinetic energy. A bowling ball and a golf ball, rolling at the same speed, will have different amounts of kinetic energy. The bowling ball will have more kinetic energy because it has more mass. If you have two bowling balls with the same mass, one is traveling at 5 miles per hour and the other is traveling at 10 miles per hour, the bowling ball moving at the greater speed will have a greater amount of kinetic energy. Another cool thing about kinetic energy is that it can be transferred from one object to another when the objects collide. When you go bowling, a bowling ball travels down the lane and the bowling ball hits just one pin, but all the pins fall down. The kinetic energy transferred from the ball to the pin that was struck and then to all the other pins in a domino effect. What is kinetic energy good for? Kinetic energy can be transformed to give us electricity. A dam gives us electricity using running water. Energy is transferred and stored, but cannot be created or destroyed. Now let's review what we've learned. Kinetic energy is energy that an object has as a result of its motion. All objects possess kinetic energy, which is determined by the mass and speed of the object. Potential energy is the energy an object has as a result of its position. Potential energy is stored energy that has not yet been released. Gravitational potential energy is potential energy that results from an object's position in a gravitational field and is equal to the object's weight multiplied by its height. For example, a book placed on a shelf possesses gravitational potential energy because of Earth's gravity. If the book were moved to a higher shelf, it would gain potential energy. And finally, don't forget that potential energy is waiting to be changed to kinetic energy in so many places, like right in your classroom. Watch our demo now. This book has potential energy, and then it gets transferred into kinetic energy. This plastic jar has potential energy at the top of this cabinet, but I'm going to transfer it into kinetic energy. This eraser has potential energy as it sits up here on the cabinet. Potential, kinetic. And finally, Miss Saris's favorite bear has potential energy. Potential energy, kinetic energy. And that's our show.
Thank you for joining us on